There's a number that haunts modern physics. It's not some elegant constant or a complicated equation. It's a measure of just how much we don't know. 85%. Think about that. 85% of all the matter in our universe is missing. And when I say missing, I don't just mean dark, like a planet that's too far away to catch the light of a star. No, this is truly invisible. It doesn't emit light, it doesn't reflect light, it doesn't even block light. It has no interaction with us, or with any part of the world we have ever known. And yet, here's the kicker. Its presence is the only reason any of this exists at all. It is the silent, unseen majority, and we are all living in its empire. For almost 100 years, we've had a name for this stuff: dark matter. We've mostly pictured it as a ghost, right? Some kind of harmless, diffused cloud that just fills up the empty space between the stars. But a new and honestly a much more unsettling idea is starting to take hold. A hypothesis that suggests the darkness isn't empty at all. It's just full of things we can't see. This is the story of the 8O hypothesis. I want you to look around you for a second. Seriously, the room you're in, the device you're watching this on, even your own body, everything you can see, everything you're made of, all of it, is just a tiny 15% sliver of what's actually out there. The other 85% is this invisible architecture, and its gravity is the glue that holds the cosmos together. It's what dictates the spin of our own galaxy. It's what sculpts the great cosmic web of superclusters, and it's what keeps the stars in the night sky from just flying apart into the void. Without it, there'd be no Milky Way, no sun, no Earth. We are here because of its influence. So how in the world did we discover something that is, by its very nature, completely undetectable? Well, the story isn't one of some single brilliant eureka moment. It's more of a slow, creeping realization that the universe, as we were seeing it, just didn't make any sense. The evidence for this invisible empire is now, well, it's overwhelming. And it all started with astronomers just noticing that things out there were moving way, way too fast. It all really kicks off in the 1930s with an astronomer named Fritz Zwicky. He was looking at the Coma cluster, this huge swarm of galaxies, and he saw something that was just wrong. The galaxies way out on the edges were moving so fast, his calculations showed they should have been thrown off into deep space, kind of like a kid flying off a merry-go-round that's spinning out of control. But they weren't. They were still held in place. Zwicky suggested they were being held by some kind of unseen matter, Dunkel materia, he called it. The idea was mostly ignored for decades until the 1970s. And that's when Vera Rubin came along and painstakingly measured how spiral galaxies rotate. Now, basic physics says stars at the edge should move slower than stars near the center, right? Just like how Pluto orbits the sun way slower than Mercury does. But Rubin found that the exact opposite. Stars at the very, very edge of galaxies were racing along at these impossible speeds, completely defying the laws of gravity. The only thing that could explain it was that the entire galaxy was sitting inside a massive invisible halo of matter, and its gravity was gripping those outer stars and whipping them around. And since Zwicky and Rubin, the evidence has just poured in from every corner of cosmology. We see its effect in what's called gravitational lensing, where the light from super distant galaxies gets bent and distorted as it passes by these giant, invisible clumps of mass. We can even see its signature in the faint afterglow of the Big Bang itself. So when you look at this chart, just let it sink in. All of human history, every star we've ever named, every planet we've ever found, every single particle we have ever seen or touched, it all fits into that tiny 15% slice. The rest, the vast, overwhelming majority of the universe's mass, is a complete and total mystery. So for decades, the search for this missing stuff followed a pretty logical path. If it's not made of normal matter, it must be some kind of new, undiscovered particle, right? A ghost in the cosmic machine. Physicists went deep underground into old mines, shielding their experiments from cosmic rays, and they built the most sensitive detectors humanity has ever conceived. They were all hoping to just catch the faintest whisper, the tiniest signal of a dark matter particle bumping into one of our atoms. It was a noble hunt. It lasted for decades, and it has been, by almost every measure you can think of, a complete failure. The two leading candidates were really elegant ideas. First, you had WIMPs, that stands for Weakly Interacting Massive Particles. These were heavy particles that theory predicted would have been cooked up in the Big Bang in just the right amount to be dark matter. It was so perfect, they even called it the WIMP miracle. The second big idea was axions, these incredibly light particles that would act like a huge, cold cloud. So we built these incredible experiments. Giant tanks of ultra-pure liquid xenon deep underground to catch a WIMP. Massive, super-cooled cavities tuned to just the right frequency to hear the hum of an axion turning into a photon. And after all that time, all that effort, the reality is just a profound, deafening silence. The experiments have found nothing. Not a single unambiguous detection. Now look, this complete lack of a particle signal doesn't mean dark matter isn't real. The gravitational evidence is just way too strong for that. But it has forced a radical reevaluation of the whole problem. These null results have basically pushed physicists to stop asking the same old questions and start considering ideas that not too long ago were pretty much on the fringe of science fiction. As one article put it, the lack of evidence has driven theorists to get more creative. And this creativity has led us to a much darker possibility. It's a new paradigm that shifts the entire search from the impossibly small to the impossibly large. Scientists are now starting to seriously consider that maybe dark matter isn't a particle at all, that the invisible majority isn't some diffuse fog, but a collection of objects. Think about that for a second. What if that galactic halo holding us together isn't a smooth, uniform cloud of WIMPs or axions? What if, instead, it's a vast swarming population of massive, macroscopic objects? Just clumps of some new state of matter drifting silently through the galaxy. Invisible stars, dark planets, primordial black holes. What if the darkness isn't empty? What if it's just crowded? This is the EDAO hypothesis. EDAO stands for Exotic Astrophysical Dark Object. The idea is that these are real, large-scale structures, maybe made of new quantum fields or some kind of ultra-cold matter, all held together by their own intense gravity. And these objects, not individual particles, are what collectively make up that missing 85% of the universe. They would be completely invisible to all our telescopes, only ever revealing themselves through the immense gravitational pull they have on the stuff we can see. And this isn't just wild speculation. The physics that allows these things to exist is rooted in general relativity and quantum field theory. The list of potential EADOs is, well, it's as fascinating as it is unsettling. You've got things called boson stars. These could be city-sized or even galaxy-sized objects made from a quantum state of matter, held up against their own gravity by the Heisenberg uncertainty principle itself. And they'd be totally transparent. Then there are Q-balls, which are basically stable blobs of a scalar field. Think of them like dark planets made of pure energy. You have the old idea of primordial black holes, not born from stars, but from the insane pressures right after the Big Bang. And maybe the strangest of all, dark stars. Giant stars from the early universe that weren't powered by nuclear fusion, but by dark matter particles annihilating at their cores. These are the monsters of the dark. And in our next explainer, we're going to hunt them, one by one. So we're left with this profound shift in how we even think about the problem. The search for dark matter isn't just a search for a particle anymore. It's a search for structure, for objects, for a hidden population that could be swarming all around us right now. Which leaves us with a final, chilling question. Is the vast, dark space between the stars truly empty, or is it just full of things waiting to be found? Join us next time as we dive deep into the physics of these cosmic monsters and explore how, against all odds, we might finally be able to see the unseen.